Hi, my name is Zhang. I also go by the name Fred. I'm a postdoc here at the Australian Institute for Machine Learning. Prior to this, I completed my PhD from the Australian National University, where I had the pleasure of working with Professor Stephen Gould and Dr. Dylan Campbell on visual and spatial understanding of human-object interactions. Now I'm working with Dr. Ehsan Abbasnejad on a subject that came to be known as task vectors. Let me tell you what I mean by that. So imagine you've got a powerful foundation model pre-trained on a vast volume of data. It's a bit of a jack of all trades but master of none. So what people do is they fine-tune these models on datasets for more specialized capabilities. Some researchers found out that if you simply subtract the pre-trained weights from the fine-tuned weights, the resulting weight delta, or known as task vectors, have some really intriguing properties. The most notable property is perhaps its compositionality. This is when you have multiple of these task vectors, each obtained from a different dataset. Then the simple arithmetic sum of these task vectors, with appropriate scaling, can help you construct a strong multitask model that excels at all aforementioned tasks. These task vectors, therefore, can function as some sort of knowledge carrier. Our most recent work draws inspiration from this and studies how knowledge can be better exploited in task vectors. We proposed this idea of anisotropic scaling, which translates to having different scaling coefficients for different parameter blocks in task vectors. Because different parameter blocks in neural networks tend to have distinct roles. For instance, the early layers extract generic features, while the deeper layers extract more specific features tailored to the task. With anisotropic scaling, we showed that task vector composition can be more disentangled, in that different task vectors interfere less with each other. Furthermore, we investigated ways to transfer the knowledge in task vectors to new tasks and found that it works particularly well in low data regimes, where otherwise the knowledge would have to be learned from massive amounts of data. Our hope is that with the large repository of models available on websites like Hugging Face, we can potentially build a significant knowledge bank, with task vectors being the knowledge carrier. So otherwise complex learning problems may be simplified to a linear combination of task vectors. In the meantime, we're looking at ways to better understand why task vectors work so well. This is where we'll need to combine theory and practice. It's certainly not the easiest thing to do. In fact, one of my favorite jokes also alludes to this point. It includes a cow farmer who found out that one of his cows has stopped producing milk. So he hired a group of theoretical physicists to pinpoint the issue, as you normally do for these kind of problems. The physicist did some investigation, and a few days later, the lead physicist came back and said, "I've got a solution, but it only works on spherical cows in a vacuum." This is a classic joke mocking the simplifications we often need to make to derive a theory. I took the liberty to extend this joke with a flavor of computer vision and machine learning. So the cow farmer is obviously not happy. He then hired a group of computer vision scientists as the next obvious move. They spent a few days investigating the problem, and then the lead scientist came back and said, "I've got a solution. I don't have a theoretical proof that it works. I don't even know why it works, but I tested this on 200,000 cows and it demonstrates state-of-the-art performance." So aside from the satire, as I said, it's not trivial how to combine empirical evidence with proper theory, but we're hoping that we can get something interesting that help us better understand these task vectors. Here at AIML, you do get a pretty strong sense of community because you're constantly surrounded by a group of people that share the same interest and passion. My favorite aspect is probably the second Friday on each month, which is when a lot of us come together in the atrium, grab a drink and just have a nice chat with everyone. Because given the scale of AIML nowadays, it's obviously not easy to get to meet everyone on a regular basis, so it's just nice to have an opportunity to catch up, to find out what they've been up to, and potentially bounce some ideas off of